Well, good morning, everyone. Welcome back to another exciting day of mathematics. Warm-up 114 is on the screen. Let's get started, please. How was home play last night? Pretty good, yeah? All right, good. I'll give you guys some time for that. Copy it. All right, show your neighbor what you got, please. You should be done by now. So you can move on for the sake of time. All right, we good? Yes, Mr. Q. All right, copy the agenda, please. Warm-up 114 is done. Rational functions transformations, we're in the middle of that. Today I'm going to introduce a new parent function, very similar to the ones we've been working with. Since you did a bunch of practice already, might as well. Hi, Yulisa. Let's go. And tonight's home play 6 more transformations. Make sure you're keeping up with your practice because it's coming. We're going to be building a lot of functions, transforming a lot of functions. All right. Thank you for sending in your warm-up. Appreciate it. And once again, a reminder, we still have a lot of people on Canvas. They're coming into the classroom, so make sure you check your mobile devices. Put them away, please. Appreciate it. All right. Access to the home plate for tonight. Here's the code. W67E3. Write that down. W67E3. W67E3. All right. So one of the home plates yesterday was this one. So your neighbor, the second home plate that you already got signed. So your neighbor, the second home plate from last night. Yeah, your screenshot. So go to Canvas, turn that in, that one and your screenshot. Tonight's home plate, look how tonight's home plate looks. Ooh, look at that. And we have quadratics in the house. Quadratics in the house. Let's go. All right, after you turn in your stuff, get a Cornell note ready, please. I'll give you guys some time. All right, y'all ready? Y'all ready? Yes? Franco, you ready? Let's go. Mariah, you good? All right. Here we go. I can transform rational functions. So we're still in the middle of transformations, rational functions, but today I'm going to introduce a new parent function for rationals. And then we'll go from there. But where have we been? We know what rationals are, so in your own words, tell your neighbor the definition for rational functions in your own words. What are rational functions? All right, type it in there, please, on your screen. Definition for rational functions in your own words. What are they? All right. All right, some of you are writing rational equations are equations with fractions. Very good. Bless you. Some of you are writing equations with fractions that have polynomials. Yes, that is correct. Bless you. All right, so it looks something like this. Yes, equations with one or more rational expression or one or more fractions with polynomials. Okay, I give you guys steps for graphing and writing. We talked about our regular rule. And we talked about asymptotes. We've been using the asymptotes, but we've also been using those values or parameters for transformations. That's what we did yesterday and last night for home plate. Yes? Any questions on last night's home plate? Pretty straightforward, yes? All right. Therefore, that brings us to today. Copy this one, example Q. It reads, rewrite the function and graph f of x equals 1 over x squared. Get a coordinate plane on the right-hand side from negative 8 at 8. Give you guys some time. Go. Just copy the problem, don't copy the steps. This is something we already know what to do. All right, here we go. You wrote this one down, but let me backtrack a bit. Look up, please. When we started with rational functions, write your utensils down, look up to the screen. We started with f of x equals 1 over x. And we know that the VA is x equals 0. The HA is f of x equals 0. And when we graph that, our VA is here. Our HA is here. And when we started with this, we made a table, is that correct? But now we just use 1 point on each side, so 1 to the left, 1 down, 1 to the right, 1 down. And once again, you're just paying attention, don't copy this. And we know what to do with that, is that correct? Now, transformations, look up, begin with g of x. Why g of x? Because it's no longer a parent function. This tells us that it's a transformation. So last night you did stuff that looked like this. Is that correct? What is the same? The 1 on the numerator and the x on the denominator. But now we have two parameters that tell us to move this in what direction? Where do we go? Mario. To the right, 3 steps. Up 5. So to the right, 3 steps. 1, 2, 3, 5 up. 1, 2, 3, 4, 5. This is our new asymptote over here. And if we move those points with it, 1 step to the left, 1 down, 1 step to the right, 1 up, and there you go. Are we there? Okay. So, today, we're moving out to a new parent function that looks very similar to this one. Look at it. Tell your neighbor, the only thing you notice that's different. Everyone, what's different? The square. However, the rest is the same. So let's start off with our VA. Tell your neighbor what the VA is on that one. VA is equal to what? Yeah, x equal to 0. HA is f of x equal to 0. So let's plot those. 0. And 0. Annette, can you get the light, please? Just so that we can see the colors a little bit better. Is that better? Yeah? Some of y'all? Okay. All right. However, since this is a new function, what do I do to graph that? Think about it. If I was to drop you guys off in a mountain that was like 10 hours away from civilization, there's no food, there's wild animals, and you had to poop. So the only way to get off is to graph that. Tell your neighbor, what would you do to graph that function? What would you do to graph that function to get off that mountain? What would you do? Or are you just going to stand there and like look at people as you're pooping in your pants? What do we do? Mario, pass them one. Joseph. What? With any function, what would you do to graph any function in the world if you didn't know the function? Very good. Make a table. Bah. And tell your neighbor what values for x would we use as our bread and butter. Everyone. Very good. -2, -1, 0, 1, and 2. Come on, people. Let's go. So, we use this to the second power. So, if I substitute -2 in here, what is -2 squared? -2 squared, 4. Next, what is -1 squared? Oh, my bad. 1 over 4. 1 over 4. 1 over 4. What is -1 squared? Bless you. 1. What is 1 over 1? 1. What is 0 squared? 0. Can we have 0 in the denominator? What would we write? Undefined. That is correct. Next, 1 squared. 1 squared is 1 divided by 1 is 1. 2 squared. 2 squared is 4 with 1, so that's 1/4. All right, let's wrap that. Bless you. -2 1/4. -2 1/4 is right here. -1 1 is right here. And we sketch our graph. 0 is undefined because we have a asymptote. Let's go to 1 1. 1 1 is right here. 2 and 1/4 is right here. And this is our new rational function. You guys notice the difference between what we started with, now where we're at? Okay, let me go back to the previous one. Here's the previous one, down here and up here. Whereas this one is back to back. Or I call it the JLO graph. Ooh, JL. You guys see that? JL, yeah? All right. So, from now on, whenever I say parent function 1 over x squared, we don't need to make a table. We just do the asymptotes, and we use 1 point, 1 step to the left and 1 what? Up. 1 step to the right and 1 up, and we are able to graph those two. Are we there? All right. So, from there, the new transformations, look up. I want you to write transformations. Are going to start with g of x with 1 on the numerator, but on the denominator, it still needs to have the x with a squared, but it's going to look like this. Look up. Do you guys notice that this is similar to this? Yes, because of the what? The little squared. However, now with this, we are able to move this entire graph according to these parameters. So let's see. Those of us that did the home play last night. Look up. Look up, look up, look up. Tell your neighbor, where would I move these components according to what we have here? Where are we going to move that to? Tell your neighbor, please. Where do we move that to? All right, where do we move that to? Let's go with Abby. Where do we move that to? 4 to the right and 3 up. Hands if you see that. That is correct. So that means I would take this 4 to the right, 3 up, asymptotes first, and now we just need the graphs. So from the center of the asymptotes, 1 to the left, 1 up, 1 to the right, 1 up, and that would be my transformation. From 1 to 5, I'll come to borrow you with this so far. Okay, not bad. 5, 4, 5, 4 is okay. Let me send you the screen so you can send me your notes. There it is. Send me your notes, please. So for tonight, I do not want a table. I want you to graph the parent function now using what we know, and the transformation using what we practiced last night. Okay, we good? Yes, Mr. Q. All right, copy this one. Example, supercube. Write that one completely, so like that you have one example complete. It reads, rewrite the function and graph transformation from the parent function, g of x equals 1 over x minus 2 squared. We'll do this one together so we can go a little bit faster. Copy it first. All right, here we go. First things first, look up. You look at it and you're like, what is the parent function? The parent function is 1 over x. Is that correct? No. This one has a what? So we would write squared. Now that's the parent function. So we need a VA, which is 0, and HA, which is 0. So let's do that really quick. 0. And 0. Bless you. Next, since this one is a squared, tell your neighbor where I go from here to plot my points to graph my graph. Tell your neighbor, where do I go from the center? Caesar, where do I go? 1 to the left, 1 up. That is correct. Plot your point, graph. Go back to the center, and what do I do? 1 to the right, 1 up, and that's my parent function. Okay, so I got this. There it is. But now I need to transform it according to this. Tell your neighbor where I'm going to move this to according to that. Talk to your neighbor. Where am I moving that to? All right. Kenyon, where am I moving that to? Close. 2 to the right. Hands if you agree with that. 2 to the right. Any steps up and down? No, just 2 to the right. So we go, from here we go 1, 2. Get your asymptote right here. The other one right there. I'm going to make it a little bit bigger so like that you guys can see it. And from here, I go 1 up, 1 to the right. I'm going to do that in black. 1 up, 1 to the, 1 up, 1 to the left. And from here again, 1 up and 1 to the right. And that's my final g of x. All right, send me your notes, please. From 1 to 5, how comfortable are you with that so far? 4.5, 5, 4, 5 4s, okay. All right, let's do another one. Here we go. Example mega Q. Example mega Q. Same process, and now they give us g of x equals -1 over x plus 3 squared plus 2. I'll give you a head start on this one. Set your coordinate plane on the right side. Remember, start with the parent function and then move on to the transformation. Go. All right, here we go. What do we do first? Let's start over here with Denise. What did you do first, Denise? The VA for the parent function, right? So it's f of x equals 1 over squared, okay? And we got the VA 0, HA 0, okay? For the parent functions, it's always 0 because if you notice here, there's nothing next to the x. I'm sorry, in blue. There's nothing next to the x. And there's no constant here at the end. That's why it's 0. Yeah. All right. So to graph this, we said 1 to the left and 1 up. 1 to the right and 1 up. All right, hands, if you got up to right there so far? Yeah, we got it, right? Next, we need to transform it according to this. However, we need to rewrite this one. You're like, what? Yeah. What needs to be in the numerator only? Tell your neighbor, what's the only thing that needs to stay in the numerator? The only thing that needs to stay in the numerator. The only thing that needs to stay in the numerator is what, Joseph? The 1. That means we need to get rid of this negative and move it to the front. Therefore, our new transform function equation is that, but with a negative in the front. All right, here we go. So according to this, where are we moving this? Tell your neighbor. According to this, where are we moving all this? First movement. Where do we go? Let's go with Geo. To the what? To the left, 3 and 2 up. Very good. 3 to the left. 1, 2, 3. 2 up. So we end up here. So the center of the asymptotes is now here. So that you can see it. Here it goes. We are here now. And here. So we move this over here. Okay. So now, if I was to graph my point, this one, it would be 1 to the left, 1 up from here. 1 to the left, 1 up. 1 to the right, 1 up. However, what does this do to these points? Tell your neighbor. It flips them. So instead of going 1 to the left, 1 up, we go 1 to the left and 1 down. This one as well, 1 to the right, 1 down. And this is our g of x. All right, send me your notes, please. From 1 to 5 up to right there. Wait for a pass. How are we so far? 5, 5, 4, 5, 4, okay. So what have we learned? Well, Mr. Q, that the 1 has to be on top by itself. Yes, that is correct. The 1 by itself on top. What else? At the bottom, I need a parentheses with a squared with an x and something inside and a number over here so I know where to move it. Okay? Are we there so far? All right. Therefore, copy this one. Example super duper Q. G of x negative 2 over x squared plus 8x plus 16 plus 7. Ooh, let's go. Get a coordinate plane to the right as well. I'll give you guys a minute to do that. Go. Copy it first, and then we'll go over this one together. All right. So, let's begin. Y'all ready? Look at the denominator. Does it have a square on the denominator? So therefore, my parent function is f of x equals 1 over x squared. Is that correct? So the first process is the same. So our VA is x equals 0. Our HA is f of x equals 0. So let's plot those. 0. And 0. And the parent function, this one is 1 step to the left, 1 up. 1 step to the right, 1 up. There it is. Okay. So, question. What do you guys notice on our transform equation? What needs to be on the numerator? No, 1 needs to be. Only. What is the only thing that needs to stay on the numerator, everyone? 1. And right now we have a negative 2. Next. Don't we need to have a binomial on the denominator with a little square? Yes? All right, which means we need to factor, aren't we? Yeah? So let's rewrite this. So I'm going to write g of x equals, I'm going to move the negative 2 to the front, negative 2. The positive 7 stays where it's at, and we need to factor this. All right. How do you factor this? Remind your neighbor. $16 and 8. What factors of 16 add up to 8? Everyone. 4 times 4. So that means we would write x plus 4. But since it's 2 of them, what would I write? X plus 4 what? Squared. That is correct. And what stays on top if I move the negative 2 to the left? I put a 1. Now we know what to move and where to move parts. Is that correct? So tell your neighbor where we're going to move all this according to our new g of x. Where we're going to move that to. All right. Ashlyn, where are we moving it to? 4 to the left and up 7. That is correct. 4 to the left, up 7. Right there. So let's get our vertical asymptote. Oh, my goodness. Our vertical asymptote. Horizontal asymptote. If I was to place the points, it would be from here 1 step to the left, 1 up, 1 step to the right, 1 up. Is that correct? So far? However, look up. What does this 2 tell me to do now? Tell your neighbor, what is that 2 telling me to do? 1 to the left and 2 up first. 1, 2. 1 to the right, 2 up. Then, what does this negative tell me to do with those 2 points? Flip them. That is correct. So instead of 2 up, I'm going to go 2 down and 2 down. And this is my g of x. All right, send me your notes, please. All right, before I move on, turn to your neighbor and walk them through the entire process for this one, please, just to make sure they got it. Walk them through the entire process. I'll give you guys some time. Share with your neighbor, please. All right, look up. So look at this one. Don't copy it. We know the parent function. Tell your neighbor, what do we need to do to rewrite that? Tell your neighbor, what is the first thing you would do to rewrite that? What do we do? Don't copy it. Don't write it down. Just explain to your neighbor. What do we do? All right, Elijah, enlighten us. What do we do? Move the 4 to the front. And then? Do the what? Oh, for the denominator Power Rangers? Bring the 5 down. What do I write on top? A 1. So 9 and negative 6. What two numbers multiply? Give me 9. When you add them, give us negative 6, everyone. Negative 3 and negative 3, or x minus 3 squared. Don't copy this. I'm just going through the process. Next, we're going to move our parent function to. Tell your neighbor, where do we move it to from there? Where do we go? Evelyn, where do we go? Three to the right and 5 up. That is correct. 3 to the right, 5 up. You get your asymptotes. Then 1 up, 1 to the left, 1 up, 1 to the right. However, this tells us to do what instead of 1 up for each side? We go how many up? 4. 1, 2, 3, 4. 1, 2, 3, 4. And our graph is going to be over here. Okay? We're good. Let's move on to these. Copy this one. Star Wars Q. Ha, ha. Ha, 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 ha. Ha, 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 ha. G of x equals 1 over x squared minus 36 plus 3. Copy that. For the sake of time, I'm going to start with the parent function. Does it have a square on the denominator? Yes. So my parent function is f of x equals 1 over x squared. So my VA is x equals 0. My HA is f of x equals 0. My points, 1 to the left, 1 up. 1 to the right, 1 up. So that's my parent function. Okay. Now, if I was to ask you where are we going to move this to, you're like, I can't tell, Mr. Q, because isn't this supposed to be in a parentheses? Yes. This one's a little bit different. However, this does tell us to move in what direction? Up 3. So what do we do when we get something like this, Mr. Q? You set it equal to 0 and solve. So what do I do to leave x by itself, everyone? Plus 36 plus 36. X squared equals 36. How do I solve for x? Renzo? Square root to both sides. That leaves me with x equals plus minus 6. You're like, what? What does that mean, Mr. Q? That means that now we have 2 VAs in the denominator. Watch. One of them is over here. The other one is over here. All right. And let's see. What is my HA? My HA is 3, or we move it up 3. So 1, 2, 3. So what you guys notice that we split up the VA into 2 now. Is that correct? So now look up please, so you're going to miss it. One of the graphs is on the left side of the VA, is that correct? So now we have this one on the left side, so that means I go here, 1 step to the left, 1 up. And I have this one on the right side of the VA, so I go to the farthest VA, which is this one, and I go 1 to the right, 1 up. And now we split up the graph like that. However, look up, we have a major gap in here. This is what I want you to do. When you end up with these 2 on top and the major gap in here in between, I want you to do this. There you go. Copy that, please. About 10 apples, Mario. Pretty good, yeah? All right. Send me your notes. Let me send you the screen. Hold on, not that one. That one. There it is. Do we have time for one more? No, that's fine. So you're going to have a couple of these for the home plate. Some of the other ones with the trinomials in the denominator. So make sure you put in some work, please, for your practice. I'll stop the video right there. Those of you following on YouTube. Once again, here's the home plate for tonight. There it is, 6 of them. And this is your code to access that home plate. All right, see you guys next time. Peace.